Lesson 42 today, finding permutations and combinations. All right, before we get into permutation and combinations, we need to talk about another symbol that is very important to understand what it means as we go through this. And this is that exclamation mark right here. Okay, what that means is, well, first, if we're doing this 7 minus 1 factorial, and that's what this is called, it's called a factorial. First, we deal with everything inside the parentheses. So, this problem turns into a 6 factorial. All right, a factorial simply is, what we're going to do is we're going to take this 6 times every single number below it, all the way down to 1. And then we multiply all those together. So 30, 120, 360, 720. Alright? And what we're going to use that for is we're going to figure out like how many different combinations of numbers can happen in something. Alright? If we go to this next one, we have 8 factorial, so we can do the same thing here. Over 2 factorial, well, 2 times 1 is 2, times 2 times 1 is 2, times 3 times 2. Okay, and what you can do with these is you can actually simplify these down a little bit. If you wanted to, well, 2 times 2 times 2 is 8, so then we're down to 7 factorial here. And then we could take this 3 and simplify with that 3. So then what we have is we just have 7 times 6 times 5 times 4 times 2, and that leaves us with 1680. Alright, so there's ways to do this without grabbing the calculator. You could multiply all that out, it might take a little bit longer, but you could definitely do that. Or you could, now one reason why I showed you how to do it this way is there is a button on your calculator that lets you do this expression. Okay, this factorial is on just about everybody's calculator. You can grab that. Okay, you're going to have to find it on yours, but you can grab it and use it. Well, sometimes the numbers get too big for the calculator to even figure out. So that's why you would have to do it this way. Alright, when we come down here to this problem here, what you're going to start doing is you're going to start simplifying these as much as you can. 5 factorial is 120 divided by 2 factorial is 2, 5 minus 2 is 3, 3 factorial, 3 times 2 times 1 is 6, 120 divided by 12 is 10. And that's something you can do in your head very easily. Alright, if we go to the next one, 9 factorial. Okay, that one's going to be a little bit harder to do, but what you could do is you could rewrite this as 9 times 8 times 7 times 6 factorial. And I stopped at 6 factorial for a reason, because what I see here is 9 minus 3 is also 6 factorial. And those cancel each other out. And then we're left with 3 times 2 times 1. Well, then we can simplify this down. 3 goes into 9 3 times. 2 goes into 8 4 times. And then we're left with 7 times 4 is 28. 28 times 3 is 84. So this whole thing turns into an 84 where you can do that whole thing without even grabbing your calculator. And then all it says to do here is to add these. So we add these two together. 10 plus 84 is 94. Alright, you can do the exact same thing with multiplication. You just got to simplify your fractions first. Okay, and when you simplify this whole thing, this turns into a 10. Simplify this whole thing, this turns into an 84. Multiply those together, we get 840. Alright, now one place where we use this is when we deal with permutations. Permutations are a selection of items where the order is important. Alright, so for example, you pick one and you can't pick it again. Alright, where order of this event happening has to be in that order. Well, an equation that you need to get memorized is this formula right here. This n factorial over n minus r quantity factorial. Alright, now how do we deal with that? Alright, well, I will show you in this problem here. How many different three-letter groups can you have of the word Alexis? Alright, well, our n stands for how many total options are there. So, if we count up all of our letters here, we have 6 letters here. And I'm going to write this just a little bit differently. I'm going to put my P in the middle, and then I'm going to put this N. N always comes first, so I'm going to put the 6 out front. And then we've got to find what our R is. Our R is how big of our groups do we want here? Well, it says we want 3-letter groups. So we can grab that and set it up that way. Now what this is going to do is, what you could do with this, and I've had kids do this in the past, is list all the options. Okay? I'm going to start with ALE, ALX, ALI, ALS, and I can keep going and going and going. Alright, and you can see that that's going to be a long list here. So it's much better to get this formula memorized, to make sure that we know it and know how to use it, than it is to actually list out all of the different options here. Alright, so using this formula up here, it says n factorial, where, well, our 6 is our factorial, or 6 is our n, so we've got 6 factorial on top, and then on the bottom, 6 minus 3 factorial. Alright, and then simplifying this down, we've got 6 times 5 times 4 times 3 factorial, because on the bottom 6 minus 3 is 3 factorial. Those go away. 4 times 5 is 20, times 6 is 120. There are 120 different ways to have 3-letter groups that are all different. Alright, and notice, like I said, you could do this, you could list out every single one, but are you going to do it for all 120 of them? And to make sure you don't miss any or have any double up or anything like that, it's going to be really tough to do. Alright, but there are 120 different ways to do that problem there. Okay, find the permutation of 9 objects. Well, let's use the exact same equation. We've got our P, tells us that we have 9 total objects. We don't have another number here. Alright, so how big is our group going to be? Well, our group is simply going to be 9. So we've got 9P9 here. How this works, 9 factorial over 9 minus 9 factorial. Alright, so on the top we've got 9 factorial, which is, this one's a little bit bigger, so 3, 6, 2, 8, 8, 0, divided by 9 minus 9 is 0, 0 factorial. If you type that into your calculator, you're going to get a 1. Because whatever this is, we're always going to have something there, we're always going to have a group there, so we're always going to divide by 1 here. So then our answer is simply 362,880. Find the permutation of 12 objects taken 3 at a time. We do the same thing. 12 total, P, we want groups of 3. So then we set it up, 12 factorial over 12 minus 3 factorial. On the bottom, we get a 9 factorial. On the top, 12 times 11 times 10 times 9 factorial. Those go away. 12 times 11 is 132 times 10 is 1,320. Alright, a photograph is taken of a 7-person committee. In how many different ways can the people be lined up if the chairperson is in the center of the group? Alright, well, let's think about this. We've got 7 spots here. And let's see, this person needs to sit there. Alright, everybody else can sit wherever, it doesn't matter where. Alright, well, let's think about this. Alright, there are 6 chairs left. There are 6 people that need to sit in those chairs. How many different people can sit in this first chair? That would be a 6. After this guy is in his place, we go to the next one. How many are left? That would be a 5. Left after that would be a 4. Left after that would be a 3. After that is a 2. After that is a 1. So really what we end up having here is we have 6 factorial, which is 720 different ways that those 7 people can sit there, considering the chairperson has to be in the middle of the group. Alright, so how does this work with our permutations? Well, it'd be the same concept, except we have a group of 6 that can sit wherever, and then we've got our P, because the order matters, because this person has to, once they sit there, they have to stay there. Alright, what kind of group do we have? Well, we have a group of 6. So just like our 9p9 up here, this would just end up being 9 factorial. Well, down here, this ends up being 6 factorial, which is what we talked about here. Find the number of distinguishable permutations of the letters in the word connection. Now, distinguishable means that we have something a little bit different here. Alright, distinguishable means if I switch these letters around, the word has to be different. Well, if you look at our O's here, if I just switch those 2 O's around, is that word going to be any different? And the answer is no. Alright, because if I switch those 2 O's, it still looks like the word connection, doesn't it? What about if I switched these 2 N's? It still look like the word connection. So, we have to have a different formula for something like this. So, what we have to do here is, first we have to know the total number of letters that we have. So 1, 2, 6, 7, 8, 9, 10. We have 10 total letters. So how we're going to do this is we're going to put total number of letters factorial on the top. On the bottom, we need to figure out which letters double up, triple up, whatever it is. Well, as we talked about, we have 2 O's here. I'm going to put those O's down on the bottom with a 2 because that's how many O's there are. If I look at the N's, well, I have 1, 2, 3 N's. I'm going to bring a 3 down here to the bottom. Do I have any other letters that double up? Yeah, I have 2 C's here also. So then there's that 2 factorial there also. And then we simply solve this one. So 10 factorial is 3, 6, 2, 8, 8, 0, 0 over 2 times 4. 2 is 4 times 6 is 24. Divide that by 24. We get 151,200 different ways of writing those 10 different letters. Alright, for our next one, at a video store, how many ways can 4 copies of an animal video, 5 of an exercise video and 3 of a Western be arranged on the shelves? Well, we're going to do the same thing as what we did up here. We want to have different ways that they can be lined up. Well, if I switch any of these 4 animal videos, that's not going to matter. It's still going to look the exact same way. Alright, so we're going to do the same thing as we did with the word connection up here. 4 plus 5 is 9, plus 3 is 12. So on top we've got 12 factorial. On the bottom, animal videos, we've got 4 of those. Exercise videos, we've got 5 of those. And Western videos, we've got 3 of those. Remember, every single time that one of these like doubles up, triples up, whatever, you need to make sure you put those on the bottom. And then you simply just multiply those out. So 12 factorial on top, and then we've got 4 factorial is 24 times 5 factorial is 120 times 3 factorial is 6. So we've got our 12 factorial divided by 17,280, and we end up with 27,720 different ways that those videos can be lined up on the shelves. Next one, so permutation is where order does matter, okay, like switching those videos around, okay, switching the letters around, okay. Combinations are where order does not matter, and when the order does not matter, you can see that our equation changes just a little bit. We still have the n factorial on top, n minus r factorial on the bottom. We also have another r factorial on the bottom. Find the combination of 10 objects taken 3 at a time. We still set it up the exact same way. 10 for total number of objects, C, and then we want groups of 3. So our 3 is our r value, equals 10 factorial over 3 factorial times 10 minus 3 factorial. Alright, and then we just multiply those out. So we end up with 10 factorial is 3628800 over 3 factorial is 6 times 10 minus 3 is 7 factorial. And that gives us 30,240. When we divide those out, we end up with 120 different ways that those can be taken 3 at a time when the order does not matter. How many different pizza varieties can be created if there are 2 choices of crust, thick or thin, and 2 out of 3 possible toppings are selected? Okay, well, does the order matter here? No, the order doesn't matter. Alright, so we have 2 choices of crust. Well, we've got to do these separately. We've got to do the crust first. So we've got 2 choices of crust. You have to choose one of them. And then we've got 2 out of 3 possible toppings are selected. Well, there's 3 total toppings. You have to choose 2 of them. Alright, well then we just set this up. 2 factorial over 1 factorial times 2 minus 1 factorial. Well, 2 factorial is 2. This ends up being a 1. So we've got 2 there. Alright, for our next one, 3 factorial on the top over 2 factorial times 3 minus 2 factorial. This is a 1, that's a 2, so, and 3 factorial is 6. So 6 divided by 2 is 3. And then it says and in between them. Alright, so when it says and, that always means multiply. Or means add, and means multiply. So we've got 6 total different pizzas that can be made here based on going through the problem here, right, and working with the parameters that they give us. How many committees can be selected from a set of 5 boys and 6 girls if each committee is to include 3 boys and 2 girls? Does the order of picking these kids matter? No, it doesn't. Alright, so if we do the boys first, we've got 5 total boys, has to be 3 of them. 6 total girls, has to be 2 of them. And then it says and, so we're going to have to multiply these. Alright, so then we set this up. Okay, using the equation just like we did before. Alright, for our first one, for our 5C3, we get a total of 10. For our girls, we get a total of 15. We need to multiply those together. We get 150 different committees that can be formed by using those parameters. Alright, on a final test, students can choose to answer 7 out of 10 multiple choice questions or 3 out of 5 essay questions. How many different choices do students have for completing this test? Well, we've got 2 different options here, right? Does the order that you do these problems matter? No. If you wanted to do problem 9, you could do it first and then skip to 2 and then 3 and so on. Order doesn't matter. Alright, so say we worked with multiple choice. That would be 10C, 7. Or say you want to do the essay questions. That would be a 5C3. What sign goes in between? Well, this is an or problem. You can either do the multiple choice or the essays. Alright, so that means that we have a plus there. So 10C7 gives us 120 plus 5C3 gives us 10. There are 130 different ways to complete this test. Next one, how many 4-letter passwords can be made from the first 10 letters of the alphabet if no letter is used more than once in the same password? Alright, now, is this a combination or a permutation? Does the order matter? Okay, if no letter can be used more than once, that tells me the order matters. So this is going to be a permutation here. Alright, we have 10 different letters to choose from. So we've got 10P, and we have to use 4. So 10P4, putting that into our equation, we end up with 5,040 different passwords that can be used there. How many sets of officers of 3 people can be selected from a club that has 22 members? Alright, does the order matter here? Do you have to be chosen? Does it say that you have to be chosen in a certain order? No, it just says how many different groups. Okay, so whether you're chosen first, second, or third, that doesn't matter. Alright, so is this a combination or a permutation? This would be a combination because that order doesn't matter. Our n value would be a 22. Our r value would be a 3. And then we just plug that into the formula. And we end up with 1,540 different groups that can be selected from those 22 members. All right? If you have any questions, please let me know.